Okay, so in our previous segment, we learned Newton's second law of motion and how it was related to momentum. So a external force acting on a system will cause the momentum of that system to change with respect to time. So first, we want to talk about what would happen if there is no external force acting on the system. So instead of F, we're going to plug in 0, so that we're going to have 0 is now going to be equal to the change in momentum with respect to time. Okay, now as long as the change in time is not 0, we can multiply both sides of the equation by delta t, and so 0 times delta t is still going to be 0. So we're going to end up with 0 is equal to the change in momentum of the system. But the change in momentum of the system is going to be the final momentum of the system minus the initial momentum of the system. So that's what delta means, the change in something. So the change in momentum is going to be the final momentum of the system minus the initial momentum. And then what we can do is, let's take this over to the other side of the equation, so that what we're going to end up with is that the initial momentum of the system is going to equal the final momentum of the system. This is going to be called conservation of momentum. So this says that the momentum that you begin with has to equal the momentum that you end with. So this is a very, very important concept in physics, conservation of something. So this is going to be conservation of momentum. And we're going to be able to use this principle in order to be able to explain various kinds of systems. Okay, I do want to mention, though, that there are other things in physics that are conserved. And so if you've seen my episode, Lesson 20, on electricity and magnetism, you should also notice that electrical charge is conserved. You can't create or destroy electrical charges. Later, in our next series of lessons, we're going to talk about energy. Energy can also be conserved. The amount of energy you begin with is going to equal the amount of energy that you end with. And then in lesson number 7, when we talk about things that are rotating, we're going to learn there's another kind of momentum called angular momentum, which is also can be conserved. And then later, we're going to talk about nuclear processes and how mass is conserved. So the amount of mass that you begin with has to equal the amount of mass that you end with. So for example, if this thing weighs 10 grams, okay, and then I pull the top off of it and then I put this on a scale and it weighs 9 grams, can you tell me how much does this thing weigh? So it'd have to weigh 1 gram. So that would be conservation of mass. But then we're also going to find out that in nuclear events, the mass of an object some of that mass can be turned into energy, and energy can also be turned back into mass. So this is according to Albert Einstein and his very famous equation, E equals mc squared. So there are other things that are conserved in physics, but these are the ones that I want you to be kind of familiar with. Okay, let's take a break, and when we come back, we're going to do our first kind of math problem involving something that explodes.